So today, we're going to dive into one of the most famous stories in all of science, the race to figure out the structure of DNA. And it's a story you probably think you know, but trust me, the real story is so much more complicated and way more controversial.
I mean, ask almost anyone. Who discovered the structure of DNA? You're probably going to get the same answer you learned in biology class.
James Watson and Francis Crick, right? Their double helix model is absolutely iconic. It's a symbol of this massive breakthrough that changed biology forever. And for a long, long time, that was the whole story. And a chapter.
But what if the key, the actual physical key that unlocked this entire puzzle, wasn't really theirs? What if the historical record, when you really look at it, points to someone else, an indispensable contributor whose work made the whole thing possible? Well, that contributor was Dr. Rosalind Franklin, and her story, wow. It doesn't just add a new chapter to the tale. It basically forces us to go back and reread the entire book on this incredible achievement. And let's be super clear here. Her work wasn't just some minor detail. Franklin provided the hard evidence, the actual physical data that was absolutely essential for building that final model. You could say that without her data, there was no solid ground to build on, just a theory. So how did she become the one person who could get this crucial piece of the puzzle? Well, to really get her impact, you have to understand that Rosalind Franklin was already a top-tier scientist long before she ever pointed an X-ray beam at a DNA molecule. Her whole career was a masterclass in building expertise. She gets her PhD from Cambridge, then moves to Paris. And it's there that she becomes a world-leading expert in this incredibly difficult technique called X-ray diffraction. So by 1951, when she joins the DNA project in London, she's not just another researcher. She is one of the best people on the planet at what she does. And that expertise shaped her entire approach to science. Franklin was all about rigorous, data-driven work. You didn't just jump to a conclusion. No, you let the evidence slowly, carefully build the conclusion for you. You follow the data. And this approach is absolutely critical to understanding what happens next. You see, it was this perfect storm of world-class skill and a relentless data-first philosophy that led her to capture the single most important piece of evidence in the entire DNA story. Okay, so what is this technique she mastered? X-ray crystallography is, in simple terms, kind of like a camera for molecules. You shoot X-rays at a crystallized molecule, and as they scatter, they create this shadow-like pattern. If you know how to read that pattern, you can actually work backward to figure out the molecule's precise 3D shape. It's brilliant but incredibly difficult. And this was no simple snapshot. We're talking about countless hours of painstaking work, refining her equipment, preparing these unbelievably delicate DNA samples. And then in May 1952, working with her student Raymond Gosling, she got it. The perfect shot, the image that would become legendary, photograph 51. Now, I know what you're thinking. It just looks like a fuzzy X. But to a trained eye like Franklin's, this was a eureka moment. That X shape, that's the unmistakable signature of a helix, a spiral. The spacing of those smudges gave her the exact dimensions of the spiral. The darkness of the spots told her it had to be a double helix, 2 strands with a big phosphate backbones on the outside. This wasn't just a picture. It was a blueprint for the secret of life. So, Franklin has the key. She's got the blueprint. But the story of who got to use that key and how they got it is where things take a really sharp and pretty controversial turn. This slide really gets to the core of the conflict. You've got 2 totally different ways of doing science. On one side, there's Franklin's data-first approach. Don't even think about building the house until you have every single brick measured and accounted for. And on the other, you have Watson and Crick's model-first approach. Let's build a cool-looking theoretical house and then see if we can find the bricks to make it stand up. They were brilliant model builders, but they were missing the most important brick of all. And this is how they got it. Franklin's own colleague, Maurice Wilkins, showed Photo 51 to James Watson. And the crucial part here is, he did it without her knowledge or permission. Soon after that, they also got their hands on an unpublished report she'd written that contained all of her precise measurements. And once they had her data, boom, all the pieces of their model just clicked right into place. So when Watson and Crick published their world-changing paper in 1953, this little sentence here was the only acknowledgement of her work. And that phrase, the general nature of the unpublished experimental results, I mean, that is a massive, massive understatement. It wasn't general information. It was the specific quantitative data that turned their model from a clever guess into a scientific certainty. So you can see how this chain of events didn't just lead to a famous discovery. It created a version of scientific history that left behind a really complicated and, for a lot of people, a deeply unjust legacy.
Let's fast forward a bit. The year is 1962. It's time for the ultimate prize in science, the Nobel, to be awarded for this incredible discovery. The Nobel Prize goes to Watson, Crick, and Wilkins. Rosalind Franklin isn't on that list. She had tragically died of cancer 4 years earlier, at just 37 years old. And while it's true the Nobel isn't awarded posthumously, so she wasn't technically eligible, her absence from that stage has become this powerful symbol of the failure to recognize just how central her role truly was.
So why is getting this story right so important? Because Franklin's story is about so much more than just DNA. It's a huge lesson that breakthroughs are built on hard experimental data, not just on brilliant ideas. It's a really stark case study of the kind of gender bias women in science have faced for so long. And maybe most important of all, it reminds us that science is rarely one person's eureka moment. It's almost always a team sport, built on the work of many people, including those who don't always get the credit.
Setting the record straight on Rosalind Franklin's role doesn't take away from the discovery. It enriches it. It gives us a truer picture of how science actually works. And it leaves us with a really important question to ask as we look at both the history books and the science of today. Whose story are we still not telling?